The elements, a visual exploration of every known atom in the universe. Today we are starting off our exploration with curium. Very curious curium in my opinion. Now, curium is named after, obviously, Marie Curie and Pierre Curie. Curium, curiously, was not discovered by the Curies, though. The dynamic duo found polonium and radium, but they never found curium. In fact, none of the elements named after people were discovered by those people themselves. Except Seaborger, but even that is kind of debatable. One reason is that just wouldn't cricket. Also, scientists would love to have a crack at naming things after themselves. Scientists themselves have large egos like other people too. Appearing to do so would just not work. They would be shamed out of the laboratory. Donald Trump can put his name on buildings, but any scientist caught trying to put his or her name on an element will be shamed out of the lab. It would never work anyway. Element names have to be approved by the International Union of Pure and Applied Chemistry, and I don't think they will let some sort of guy who just found an element to just name it after themselves. Moreover, the days are long gone when someone like Marie Curie could labor for months in her lab until she concentrated an unknown substance, in her case, radium, and down to the point where her beakers and funnels glowed in the dark, and all her notebooks and cookbooks to the point where they have been stored in lead-lined boxes to this day. Yeah, they were contaminated. No one can do that anymore. Since the advent of the era of the big science in the wake of World War II's Manhattan Project, no element has been discovered by just one person. Yeah, no one. These have been joint discoveries made by several researchers too. Curium was discovered by a large team led by Glenn T. Seaborg, who also discovered seaborgium, Ralph A. James, and Albert Gyorsom, using the 60-inch cyclotron at the University of California, Berkeley. Its only applications relate to its extreme radioactivity. Other than that, nothing else I can go ahead and say about curium. Next, we have atomic weight of 247. Its density is 30.510. It has a crystal structure of a hexagonal prism, but we don't even know its atomic radius. 5F is starting to climb up. I really hope they discover new elements soon. And, well, I'm not even going to mention its boiling, melting points anymore. They're pointless to the fact that they're useless. Next up, we have berkelium, named after, obviously, the California University of Berkeley. This is the longest-lived isotope of berkelium. Which one do you think it is? It's berkelium-247, with a half-life of 1,379 years. And, well, you can obviously think of that happening soon. You'll find the berkelium samples decaying in the 31st century. If you sat there for 1,379 years and somehow lived all through that time, you would only have half a pound of berkelium left. If you let it sit for another 1,379 years, you have another quarter pound of berkelium. And there's really a list of decaying berkelium too. Berkelium decays into americium, which decays into neptunium, which decays into plutonium, which decays into uranium, thorium, palladium, actinium, which can either go to francium or thorium, but if it goes to francium, well, it will instantly die. Then it goes to thorium, and then it goes to radium, radon, polonium, lead, bismuth, which could either go to cellium, which would then go to lead, or it could just go to polonium, but then both of those will always decay into lead. If you did not like my explanation, go to the website! I am not supported by this guy. I have never met the guy before. Berkelium, though, it just doesn't vanish. It is transmuting into place into americium, which itself is an isotope which will decay into another one as well, too. Its element numbers, though, not important. Its practical applications, absolutely none, except some people should be waiting for a millennia just to see what it decays into. In fact, a millennia won't even do. It'll have to take billions and billions of years, so it's not going away anytime soon. Its atomic weight is 247, its density is 14.780, its atomic radius, we don't know it. Its crystal structure, it's a hexagonal prism. And its atomic filling order, it's starting to go up a lot. Its atomic emission spectrum, though, no. Its electron filling order, as I mentioned earlier, it's going up. But atomic emission spectrum, no. We only know its solid forms, though. We don't know anything else because we never even tried to. And I don't think we'll ever think of trying. California, named after the state of California, which itself is a state of the United States of America. Eureka! California is number 98. Glenn Seaborg is the name you might put a lot around this part of your table. He's on the list of those credited with the discovery of californium, plutonium, americium, curium, berkelium, einsteinium, fermium, mendelevium, nobelium, and even seaborgium. The last one particularly is kind of ambiguous because it's his name, but most people say that discovered by Glenn T. Seaborg. So I'm guessing that's one of the reasons why they're doing this. Of course, the last one is there, just a note, and I'm not even going to discuss all these periodic table names as well, too. What you have to know about Californium, though, is that there was a pretty big debate, and California just got its name into it. That's all I'm going to say. Next up, its atomic weight is 251, its density is 15.1, its atomic radius is Na, its crystal structure, hexagonal prism. 5F starting to climb up. Please fill up the whole thing by the time we end this video. It won't even last that long. And we don't even know its other states of matter. 99, Einsteinium, named after Albert Einstein, obviously. Yeah, winning a Nobel Prize is trivial in comparison to getting an element named after you. There are more than 800 Nobel laureates, with more added every year. However, there are only 118 spots on the periodic table, and it's not easy to rename them. Einstein, though, he was a shoo-in. He won both the Nobel Prize, he won several other prizes, even the President's Medal of Freedom Prize for some reason. And, well, he even got an element named after him. Also, this happened after he died. Everyone knows Einstein, but few know that he sent the single most important letter in the 20th century. No, he didn't write it, but he did put his name onto it, too. Yeah, that's all you know. That's all I have to know about this. Alright, its atomic weight, 252. We don't know anything else after that, except its atomic filling border, and it doesn't even have an atomic emission spectrum because we haven't even been able to measure it. Last for today, it's fermium. Fermium. Now, fermium, every field has its legend, and some people say retold until they take on the air of mythology. One is how Enrico Fermi first created the first sustained nuclear chain fission reactor, and which at the University of Chicago, and this is pretty much how atomic bombs ideas were created. Yeah, we really love making weapons, do we? That's all I can say about uranium. That's all I can say about fermium. Enrico Fermi himself went ahead, just got a pile of uranium and more uranium, put them together, smashed them into each other, and boom, he got nuclear fission, also on a very small scale. Yeah. I'm not even gonna say more about this. And this is it. That's it. Its atomic weight is 257. Everything else, we don't know. We never even got to fill up 5F. My brain, my satisfaction, my OCD. That's all I can say so for now. So this is the end of today's video. I hope you guys enjoyed the episode so much. I'll see you guys soon. Until next time, Sean out. Peace. Bye-bye.